Continuing our study of circles, we're going to look at applying angle relationships in circles. We have a theorem that says if a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Now that should make sense if we go back to the inscribed angle, because in a sense this is an inscribed angle, and remember those are equal to 1/2 of its intercepted arc. So the measure of angle 1 is going to be 1/2 of the arc AB, and measure of angle 2 is going to be 1/2 of the arc BCA. So working these two here, in this example, what we're looking for is an angle. We know that it is 1/2 the intercepted arc, so 1/2 of 130 is 65 degrees. In the second one, we're looking for an arc. Well, if the angle is 1/2 of the arc, that means the arc is twice the angle, so we simply have to multiply 2 times 125 degrees to get 250 degrees. In this problem, we can find the indicated measure here. We know the angle is 1/2, so that would be 105. So you should try this one. Remember, the arc is twice the angle, so that's going to be 196. And for number 3, xy is going to be twice 80 degrees, or 160 degrees. If two lines intersect a circle in each other, there are 3 possible places where the line could intersect. They could intersect right on that circle. If they do intersect on that circle, we already know how to know the relationship between the angle and the arc. The angle will be 1/2 the measure of the intercepted arc, because that's just an inscribed angle. If it meets inside the circle, though, or outside of the circle, that presents us with different situations. If the two angles meet inside the circle, what I will see is that I've got some vertical angles here, so those two are congruent, and I've got some vertical angles here, so those two are congruent. What our theorem says is that angle 1 will be basically the average of these two arcs, both angle 1 and its vertical angle, meaning it's going to be 1/2 of the two added together, and angle 2 will be 1/2 of its two intercepted arcs added together. If a tangent and a secant, two tangents or secants meet outside the circle, and we'll see these different situations in a minute, then instead of averaging them, we're going to take 1/2 of the difference in them. So in this case, we see we have a tangent line and a secant line, but they form two arcs, and we take 1/2 of the difference of those two arcs. If we got two tangent lines, it works the same way, 1/2 the difference of the two arcs, and if we have two secant lines, it still is 1/2 of the difference. So let's look at some examples. In this case, we're looking for an angle formed by two chords that meet inside of the circle. So the measure of angle represented by x degrees will be 1/2 of the sum of those two. So we simply add them together, divide by 2. This one is meeting outside, so we're going to use our next one to say that it is 1/2 of the difference of the two, and so we work that out and get 51 degrees. So let's look at this example here. Now I'm going to tell you the way that the book worked it, and then I'm going to show you a way that I think is actually easier to work it. What we have is we've got the Earth, we've got the northern lights up here, and we're looking for this arc right here. The way that the book worked it is they found the angle outside and then dealt with, since it meets outside, the difference between the two arcs. But I also know that this arc is simply equal to the measure of this entire central angle. So if I can find that central angle, it appears to me that would be a lot easier way to work it than trying to find the difference between two things that I don't know. So I'm going to look at these. Notice these are tangent lines. BC and CD are both tangent to the Earth. And if it's tangent, it means that it forms a 90-degree angle with the radius of the Earth. And so I have a right triangle here. If I want to find the measure of this angle in a right triangle, I can use my trig. I know that I'm dealing with the adjacent and the hypotenuse of this right angle, so I know that the cosine of angle A will be equal to the adjacent, which is 4,000, over the hypotenuse, which is 4,150. I also know that I can find the measure of angle A. The measure of angle A will be equal to the inverse cosine of what the cosine is equal to, or 4,000 over 4,150. Come up with a measure of angle A is approximately equal to 15.45 degrees. But I need this entire angle here, so that is 2 times the measure of angle A, which will be approximately 31 degrees. And so the measure of arc BD is approximately 31 degrees. So let's look at some guided practice for you to try. What I'm looking for is y. It turns out that y is 61 degrees. Now, how did we get that y was equal to 61 degrees? Well, there's a couple of ways of doing it. I know that this much is 95. I've got that this is 102. So this is a linear pair between these two. So that means that this one is 78 degrees, right? So that we know that 78 is equal to the average, or 1/2 of 95 plus y. And so in this case, I can multiply by 2. I get that 156 is equal to 95 plus y. When I subtract 95 from 156, I get 61 degrees. So how about this one? I'm looking for A. I know that 30 degrees is equal to half of, this meets outside of the circle, so that is the difference between A and 44. And so getting rid of the 1/2 by multiplying, 60 is equal to I got rid of the half. 60 is equal to A minus 44. So when I add 44 to both sides, I get 104 degrees. So here's one more. Let's see what we've got here. We're trying to find the value of x. We want to know this arc out here. Well, what I need to do then is I need to find the inner arc. This is just like that problem we did a while ago. We know that if this is 3, the radius is 3, I'm going to have to add 3 here. So that means that this is 5, the entire area. I have a right triangle. Now, I could get that this is 4 real quick because of my 3, 4, 5, but that doesn't do me any good in finding this arc. What I need is the measure of this angle so that I can get the measure of both of these angles. And so what I'm going to have to do here is I'm going to use my cosine of angle TSQ. The cosine of TSQ is equal to 3 over 5. And so the measure of angle TSQ is equal to the cosine inverse of 3 over 5. So the measure of angle TSQ is approximately equal to 53 degrees. That means that this entire angle here is equal to twice that, twice the measure of angle TSQ, then is equal to 106 degrees. Since the whole circle is 360, I got 360 minus 106 will give me the measure of arc TUR, which is what we're looking for. And so if I subtract that, I come up with about 254 degrees.